Hello, my name is Thomas, and this is my team's final code review and demo for fall 2018. I'd like to show you our current demo for our crop row detection software that we've been working on. During the demo, I'll be given a brief overview of the functionality of our software. To start off with, our software program takes in a multitude of crop row images and applies some pre-processing on these images, such as grayscale transform, a Gaussian blur, and a region of interest. Once that is done, it'll find the huff lines of the crop rows and display those lines on each of the 5 crop rows. We then process the coordinates of the huff lines with the algorithm we created to determine the center of the 5 crop rows. The center line is then displayed in red on the crop rows so the tractor knows where to drive without damaging all of the crops. You can see all of this happening in this video as if the tractor was moving along the crop rows. In future releases, we'll be looking into applying machine learning by training the model with crop row images using TensorFlow. Now I'm going to go ahead and hand it over to another member of the team to demonstrate our project from the development perspective. Thank you.
Hi, my name is Kiran Gautam, and today I'm giving a presentation on this project from the development perspective. Let's dive right into the code. Um, for this project so far we have two different artifacts. One is the main algorithm, and another one is the algorithm integrated on ROS, that is a robot operating system. For the main algorithm, we are identifying the crop rows by looking at the images. So to do that, we are using a OpenCV library. That's our main library that we use to manipulate the images and identify the lines. As you can see, we have all our main global variables are defined on top. So we have our main method right here that goes through a list of things. Mainly, it lists all the images on this input folder. So it has few images that we can process. Then it just captures the start date and it just to see how fast we are processing the images so that we can fine-tune our algorithm. So basically it calls this crop row detect method, that is going through different image processing to identify the final rows. As you can see, our code is very modular. It's very clean. We have all the necessary comments on each method and some background on how it functions as well. So that's our main source code and that our team has written so far for this algorithm. Just to give you a brief explanation how this algorithm is going to work. The first thing for this we go through several image transformation. The first thing is grayscale transformation. The second thing is we blur the images so that we reduce all the noises. The third thing we do is we mask the images because we are only interested in the middle portion of the image and not the other part of the image. And finally, we actually draw the line on the images. To draw the line, we're using a OpenCV libraries method, that is HuLine probabilistic function. It's going to give us all the line coordinates for the on the images depending on the grayscale color. And finally, we are drawing the line. This is the main method that actually draws the line. The way it works is so once these HuLines gives us a bunch of lines that's like very small and randomized lines, we actually filter all the lines depending on the slope of each smaller lines. If the slope is invalid, we just ignore that, and also if the slope is valid, then we put all the line coordinates that has similar slope to one bucket. I create a dictionary to capture all the different slopes. So as you see here, we have captured all the line coordinates, all the number of lines, um, and the total number of lines here. So once we capture all the lines, depending on the slope, in different bucket, we actually iterate through those lines through that dictionary and draw the lines, right? So once you draw those 5 lines, at last we get the average of those 5 lines, and we draw the middle line right here using the OpenCV library. So if you see here, so these all are driven by all the color, all the thickness of the lines are driven by our main variable up here. It's very easy for anyone to actually tweak around and change the color or change the slope or any other algorithmic feature. Let's try to run this program right here. So I'm actually running the program. So as you see here, the first image, it went through the image transformation and it created those 5 lines and it created the middle line. So similar, that's for the other images. Let's close it. So I'm going to show you guys how what just happened, right? So if you see here, so this is the main image, right? If you see, we have first image transformation is the grayscale color. We change the whole images to grayscale. The next one is area of interest. So if you compare between those two, we are only interested in the middle part. So that's how we are masking the images. And the last final part is drawing the actual lines from the images. So that's pretty much it from the algorithm perspective. I want to dive right into another artifact we have, that's a ROS integration of this algorithm. So I have set up my Ubuntu machine with ROS. All right, so let me run the ROS code first. The way it works is we have 2 nodes. One is a subscriber, one is publisher. The publisher is going to publish the image name, and the subscriber is going to listen to the image name and process the image. So this is our subscriber right here. I'm not running the publisher right now. We have, for visual perspective, we have this nice looking graph. So right now, let's run my publisher. If you see here, this is my publisher, this is my subscriber. So publisher is publishing the image name, and subscriber is processing the image and getting the final row coordinates. So that's how we will be integrating our algorithm on ROS. In reality, our algorithm is going to be on ROS. It's going to be running one of the node in the ROS, and the camera is going to be the one that's going to be publishing the images, and that's where we're going to be listening. And once you process the image, we're going to again publish the coordinates that the vehicle is going to listen to for the autonomous driving. That's pretty much it from the development perspective. From the project perspective, our project is pretty good shape. Like we're in track. All the code, it's written by our team members in various sprints. So we have done quite a lot of research for doing that. OpenCV, ROS, TensorFlow. The only thing remaining for us regarding this project is implementing the whole algorithm using machine learning, and also integrating this ROS node to the actual camera and processing the camera images and integrating that output with the actual vehicle navigations. Thank you.
This is a project repository on GitHub. I'm going to walk you through our directories. So here's a crop rows algorithm. It basically handles drawing the lines in the crop rows and extracting coordinates. This is our ROS crop rows directory, which is basically taking our algorithms and integrating them onto ROS nodes to speak to each other in real time. And then we have the research branch, where you're basically experimenting with different aspects of the project without really committing it to the main folders. And we're actually going to move the research directory into its own branch. And yeah, I hope you enjoyed our video presentation and you got a better understanding of our code base. And going forward in semester 2, we really hope to, build on this and integrate everything in ROS and get a live final working solution. Thank you.